Okay, this lesson is going to be on enthalpy, and enthalpy is the change in heat, delta H. It's going to be a thermodynamic variable, measures the heat change in a system when we keep our pressure constant. If your delta H is negative, it is exothermic. Remember, we're going to assign it a negative sign if you are releasing heat, which means if your delta H is positive, it's going to be endothermic. Your heat and enthalpy are going to be interchangeable, so your delta H is going to equal your Q. So we're going to have the same rules here. Negative sign is exothermic, positive sign is endothermic. So because they're interchangeable, you can rearrange specific heat to get your change in heat. So delta H equals M times C times delta T. But we're going to look at the heat of the reaction. So that's going to be the heat change for the chemical equation as it is written. So in an exothermic reaction, your heat is going to be on the product side. Exo means released, so it's going to be on the product side. And because it's being released, we would assign it a negative value if we're just talking about the heat of the reaction. So for an endothermic, it's going to be on the reactant side, and that's going to make our delta H positive because you had to put heat into the system to make it go. So when you solve a heat of reaction, you have to set up a ratio from the balanced equation. So whatever your heat is going to equal the number of moles of the substance that you're talking about. So this piece right here is going to come from the balanced equation. So if we're going to calculate the kilojoules of heat required to decompose 2.24 moles of sodium bicarbonate, you're going to start with the 2.24 moles of sodium bicarbonate. They want kilojoules of heat, so we're going to put heat in the numerator. And you need 129 kilojoules of heat for every 2 moles of sodium bicarbonate. And we don't have 2 moles, we have 2.24 here. So the amount of heat required for 2.24 is going to be 2.24 times 129 divided by 2 is going to be 0.0